Hello, welcome to Learn with PMW World. In this session, we continue looking at static method as by solving an extensive example of static method. So this session is said to be part 3.0, part 3.2. And remember the other part we are looking at this. Now we have extended the static method as an example. Find this by saying we are going to create these four methods in math.utility as a class name. So to be ahead to have the overall idea, since we are saying a static method belongs in the namespace of a specific class, yeah, it's just used to wrap or group uh, functions that perform certain or similar functions. Like this math utility is performing the mathematical calculations. So this is the name of the file, math utils. Then we say this part always contain what? Attribute. And the third part of the class contain method. Yeah. However, the first part of this, in terms of this class, we are not going to include any attribute, but this class will be full of wrapped classes. So we are going to have is prime as a method which receive the value of n. We're also going to have GCD, finding a common divisor, which will have to receive an argument of a and b, and the other one will receive a factorial, right? The other last method will receive the Fibonacci value n. So this is just a blueprint we have created. Now let's make this blueprint into an existence in programming. All right, sure. So here we therefore create a class name math utility. We said that the math name at least it has to have an uppercase M, and the file name for them to be different is starting with lowercase m. Okay, as we earlier stated that we must define each static method with an annotation which is looking like this as a static method. Therefore, we said that we have this first method receive the variable n just to detect or determine if it is a prime number or not. In there, that's where some issues comes in. In prescribing the function of a method, we can say it will be receiving, it will be calculating the prime number, but how are you going to do that? That's where the logics, the fundamentals of Python you are learning from previous sessions that you have to combine in here. Okay, so the condition will be like n, the variable that will be received as an argument, if it is less or equal to 1, then return false. At this particular point, we understand what prime numbers are. These are numbers that accept itself and 1, or that are divisible by itself or 1. Prime numbers are the one that we are trying to program here. Rather than us starting asking ourselves better, we be just passing the values. So what's is 8 a prime number? Then to give us the answer. Okay. So if n is less or equal to 1, return false. Else, for we are going to create a for loop here for I in range 2 comma n. What do we want here? I'll explain this function in a moment. So in function range n, in iteration, do some sort of logics here. That means if n, remainder of I, which will be iterated, will be equal to 0, then what? Also return false. All right. After returning false, then probably from there you have to return true. Return true. Okay. I use this keyword in Python is not an issue, but let's be consistent to the way we are using the keyword. Okay, return true. So let me explain what's actually happening here. If n is less or equal to 1, return false, because prime number should be 1 or the value itself. Otherwise, for n, I, which will be variable iterating, will be assigned to iterator in range 2, comma n. The n is a value that we're trying to determine if it is a prime number or not. For example, if we receive n to be 4, so the iteration will be how many times? 2, 3, 4. It will be about 2 times, right? The first iteration will be calculated as the first iteration. This is what will happen here. That is, if it is true, if 4 remainder of I is a first iteration, which is 2. If 4 divided by 2, if there is a remainder which is equal to 0, then return false. That means it will return false. That which means 4 is not a prime number, right? Yeah. So we'll say the 4 is not a prime number. So let's try for 5. If we pass there 5 as n, then it will be like in a first iteration 5 divided by I, which is 2. 5 divided by I, is there a remainder which should be equal to 0? No, then return true. It will, this function will turn true, simplifying that 5 is a prime number. Okay, that's what is actually happening here. Shall we move? All right, we now move to a second part of a static method that will be calculating the common or the greatest common denominator, yeah, between two variables. So greatest common denominator. Yeah. So this function name will be a static method as well, but we will just won't write their own name, but we'll say common greatest common denominator. Yeah. So we are about to provide these values of the greatest common denominator. So this should be the I value, and this should be the low value. Yes, that is, for example, this argument has to receive, for example, 54, comma, maybe 32. Then it has to calculate the common greatest denominator, right? Yeah. So shall we proceed in this manner? Yeah. So this is where the part which we should know how to implement the method. What logics are we going to use to determine the greatest common denominator between two values? Yeah. So we'll just use while low value shouldn't be equal to 0, right? So as long as that low value shall never be equal to 0, then we'll implement a variable called a remainder, which should be I value the dividend remainder of low value. Yeah. So we will have to divide the I value minus the low value, then we keep their remainders. From this part, after doing so, we are going to assign the I value to be equal to the low value. I'll explain and I'll give an instance. After doing that, we also assign the low value to be equal to a remainder, right? We assign the low value to be equal to remainder. Yeah. So I'm sorry, I won't manage to comment there, but I hope you can get my explanation while watching the video so that you'll be following. Yeah. From there, then we just have to return the absolute value of a I value. Return. So this is a function in Python. So we are just borrowing from the known function. So we don't have to worry about where this is coming from. It is part of the math utility of Python. That is, we are just going to keep the I value. So we shall practice what actually is happening here. So this is just used to calculate the um, greatest common denominator. So let me give an actual example of these two variables so that we don't kind of confuse ourselves here. So I'll just copy this and give an actual instance of what is happening here. Okay. Okay. I'll put it here so that we understand. I'll paste the function here. Where is it? I'll paste the function here so that we understand what's going on. I hope you can see it right now. So let me give an example to calculate the common greatest denominator between two variables. I'll give 16 and what and 6, for which we know the normally the greatest common denominator A, it is what? It is always 2. Just correct. So I'll give an example of where we will call this function greatest common denominator. Then we are going to pass the values of 16 and 12 as we emphasize the high value and the low value. So from what we have done here, let's try to go step by step to prove our implementation if it's going to calculate the greatest common denominator. But we know 2 can go into the variables, but we expect the 4 to be the greatest common denominator, right? Yeah. This is just an example. That means we can pass n bigger values of 54 and 28. We can pass there as an argument. But I just want you guys to understand this implementation, how it is working. So we are saying after we pass those values, we are saying wow, low value, which is 12, should not be equal to 0. It is true. So as long as that low value of pass is not equal to 0, then we are going to say the remainder is equal to I value, which is 16. We divide by the low value, which is 12, and we keep the remainder. So 16 into divided by 12, we shall remain with 4 as a remainder, right? Yeah, we shall remain with 4 as a remainder. So this variable in the first iteration is going to keep what? 4 as a remainder. So remainder will be equal to 4. Then the second statement is going to assign that I value to be equal to low value. That means I value to be kept like this. I value will be equal to low value. What's the low value here? It is 12. The low value is 12, as we pointed out. The low value is 12. That means the I value will be assigned to 12. Then the second statement will say, now that low value assign is to a remainder. Shall we do so? Low value we assign it to a remainder. And we said the remainder was what? Was 4. We say equal to 4. And just like that. So return ABS as I value. So what's the I value here? I value is 12, right? I value is 12. Then it will iterate again, because we are saying as long as the low value is not equal to 0, we haven't ended, because this is a loop. So it will come out while it has returned the I value to be 12. So it is there outside. So the second part will be is low value. In this instance, it is 4, then it's going to assign is 4 not equal to 0, which is true. Then you are going to do the same. Remainder is equal to I divided by law. So this is the second part of iteration, right? This is the second part where low value, in this instance, low value is equal to 4. So this is the second part of our iteration. The first part of our iteration, I've explained what has happened. So the second part is it is going to assign the remainder, which is I value. Now the I value this time, it is 12. So 12 divided by 4, right? 12 divided by 4. This 4 is a low value, and I value, we said is 12. That's why you're saying 12 divided by 4. That's the second iteration. So then we keep the what? The remainder. So remainder, which is 12 divided by 4, there is no remainder. So the remainder here is equal to, will be 0. Then the second statement will be like I value is equal to low. I value is equal to low. What was the low value? The low value is 4, to say 4. Then that's low value will be equal to remainder. So low value will be equal to remainder. So now what's the remainder here? We said that the remainder is 0. Then the loop will come out, then it will test. The loop is coming out, which has assigned the low to be the remainder, and the remainder at the second iteration is 0. So low now it will be 0. As long as low is not equal to 0, but now 0 is equal to 0. So this statement is false. Then the loop will stop working and it will keep the last value, which it has returned to be what? To be 4. Right? I hope you have understood this explanation. So it will maintain the absolute value. That means regardless of when we are dealing with negative numbers where we had -4, it will return to +4. That means if we had passed argument to be -16, maybe, or -12, depending in the situation, to always return the positive value, right? Yeah. So this is what's actually happening in this function. I hope you have understood this part. Shall we move to the next part of this calculation, which is another static method called a factorial. Yeah, I hope you know how a factorial works. So a factorial actually multiplies the sum of those numbers in a sequence. For example, if we have 3, then it will try to multiply the sum of the sequence from 1 to 3, then it will return. That's a factorial, I think, in a simple explanation, right? Yeah. So we'll say factorial, which will be receiving n. For example, if I pass 4, it has to return the factorial of 4. And people always say the factorial of 0 is 1. So we're going to keep up with that rule. Though in this video, I'm not going to prove how it came to be 1, but for now, they were a mathematician who did such kind of operation, and it's another step to explain why a factorial of 0 is equal to 1. I hope that side you can also compute. But for now, we have kept the rule that a factorial of 0, it will be 1. So let's do this, where we'll keep for I in range 1, comma, n plus 1. Right? What will happen here? We just want to iterate the values, the value that we are trying to factor out to answer the factorial will be adding to 1. So we'll just keep the iterations here, the loop, which means that result will be assigned to, will be multiplied by I. And this is just simple, too simple. Then return result. Yeah, as simple as this. So should I also explain what this is working for us to prove ourselves? So I'll take you back there as well, and I'll give an example of 3. Oh, we won't reach there. Let me just explain from here. Okay, let me just explain it here so that you also get it. So we are saying that if we call this method factorial, then we pass the argument of 3, right? Yeah, want to answer the factorial of 3. So when this method runs, it's going to do this operation. Is out to be equal to 1. So here it has to retain this out. We know that this out is equal to 1. So for I in range 1, comma n plus 1, that is 3 plus 1, which will be 4. So guess what? How many iterations will occur here? Iteration will be 2, 3, 4. So the iteration will be 1, 1, 1. So the total iteration shall be 3. So this loop will go through 3 times, then to do some operations in there. So for the first iteration to be like result is equal to result. That's what this means. I've just expanded it. Is equal to result times 1, and keep the answer to the same variable, which will be 1 for now. Since this result for a start is 1, so the answer will be 1. Okay. So now second iteration would be like result, the second iteration, right? Result is equal to, so we kept the result to be 1 times, this was a mistake, my bad, this was a mistake, there shall be I variable there. Yeah, so the first one is okay. So result, now the second iteration I will be assigned to 2. The second part will be assigned to 2. So it'll be like result I times 2, and this which will keep the sum to the answer to be 2, right? So now the third iteration of which I shall be equal to 3. Okay, then we know that the result was 2, so multiply 2 times 3, and it will be what? 2 times 3 is 6, right? Then the fourth iteration, um should it be the fourth or the fourth iteration? How many times? 1, 2, 3, 4. Okay, we had some mistake here. So iteration will be only 2 times, since 1, 2, 3, and 1, 2, 3, and we'll reach 4. So in the box there, we shall have 3 iterations. So the last iteration will be like this, and this will be the answer, and it will retain this result, right? So n factorial, for example, we put 5 in there, it's going to do the same operation. We just multiplying the values from 1, 2, 3, 4 up to 5. Then it will return the sum of these values. Yeah, that's it. Okay, so we come to the last part of these explanations, where we are going to determine the Fibonacci. You know the Fibonacci series, where we calculate the sum. Factorial is calculating the product of the answer to the preceding sequences, but now the factorial, the Fibonacci calculates what? Calculates the sum of the values starting from 1 up to that value I've specified. For example, the sum of the first, the sum of the Fibonacci of 4, it will be 11, right? So we'll be calculating 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 2, 4, 4 plus, just like that, up to the extent we reach 4. Then to return the result. That's what we want to calculate in this guide. So even in this situation, the logics are actually simple. Yeah. So we also keep the result to be equal to 1, and it will be one and the same of this thing. The only difference there will be what? There shall be an addition. So nothing strange from there. For I in range I is equal to n plus 1, then just a result plus is equal to I is equal to I, just like that. From there, then we shall return, return result. Yeah, as simple as that. And let's actually demonstrate it. Since we are saying these are static method, so we have to include this keyword. Yeah. So now let's create a program file. Then we demonstrate these 4 static method we have created. Okay. And we said the syntax of calling static method shouldn't be an issue. So we are going to call this one, oh, it shall return the value of true, right? Yeah, to determine the prime number. So we shall say status is equal to math utility dot, what is the function name is prime, is prime. Then we pass the argument of 11, so that will determine if that value is a prime. Then we print with some words in there. Status, print status. Status, so we can give some logics here. If to say, so we shall say status of 11. So if it turns true, that means if it turns true, that means 11 is prime. Status prime. Okay, then it has to return true. Then also we go to a greatest common denominator. We call that method. So this one is just returning the value, so we can access it directly. So we can just say print greatest common denominator of 12 and of 16 and 12. Then we shall pass the argument in there, which will say math utility dot g CD. Then will be like 16, which is I value, and 12. So it will return the greatest common denominator. From there, we shall also call the factorial, of which it is returning result. So we can directly access it in a print function. Okay, formatted. So factorial of 4. So these are just small values that we are demonstrating. Then we shall say math utility dot factorial. Then we pass argument as form. The last one is a Fibonacci. Fibonacci of, maybe we shall give Fibonacci of Fibonacci, I think this is of 17. It should return 154, I guess. So we can access it directly. Dot Fibonacci. Then we pass 17. Okay, without errors, we expect the good answers from A. Let's learn this program. Okay, let's learn. We first try to look out if we have any errors in the definition of functions. Okay, usage while this expect a full colon there. Okay, now let's demonstrate what we just did from there. Okay, so we compile the program Python math utility dot py. Okay, wow, it comes from there. So it has brought the status prime number, which is 11, it is true, right? Yeah. Then the GCD of 16 and 12, 16 and 12 is 4, right? Then the factorial of 4, factorial of 4, it has brought 1. Okay, we'll go back from there. This is not what we expect. Then Fibonacci of 17, it is 54, which is correct. So let's try to figure out why this value, we pass argument of 4, then it brought 1. This is so-called a logical error. So factorial, okay, this is the issue here. We had to put the value of I because it's the one that should be iterated, right? Yeah, this part, not 1. So there was some similarity there. We tried to compute. Great. And factorial of 4, it is 24. We can try to prove that, but this is the answer. Factorial of 4 is 24. Now let's change this variable for a prime to see if it can return. Is 12 a prime number? Let's see, because it has to bring the status of false from there. All right, then we are doing the right thing. In summary, we focus on a class method and static method, and we have demonstrated the implementation of this part. In the next video, we'll be looking at encapsulation and properties. It's important we go from there. So once we are done in encapsulation and properties, then we will no longer be saying that introduction to object-oriented programming, because at least you know these fundamentals and the other core concepts that we early introduce. Yeah. So in the next video, we'll be looking at encapsulation and properties. Thank you for watching. See you.